Hello students. Today we're going to look at transformations of functions, and we're going to be focusing on translations and reflections. Basically, we're going to look at how we can change the equation of a function and what effect that has on its graph. We're going to start by comparing the graphs of two functions, and then we're going to look at some rules for these transformations. So what we want to do is we want to graph f of x equals x squared. And then also we're going to want to graph g of x equals x squared plus 2. Now we're going to make a table of values here. And we've already done this before for f of x. So I'm just going to put the values in. When x is -3, -2, -1, 0, 1, 2, and 3, we know that when we square these, we get 9, 4, 1, 0, 1, 4, and 9. I think we've done this graph at least a couple of times at this point. Now what I want to do is I want to look at a table of values for g for this other function. Let's take a look at x and g of x, and I'm going to pick the same x values here. Now our function g of x takes x squared and adds 2 to it. So we know that -3 squared is 9, but then we add 2 to that and we get 11. -2 squared is 4. When we add 2, we get 6. -1 squared is 1. When we add 2, we get 3. 0 squared is 0. When we add 2, we get 2. And then we get the same things for 1, 2, and 3. We end up with 3, 6, and 11. Basically, we're taking what we got for f of x and we're adding 2. Now let's sketch both of these graphs on the same xy plane to see what the relationship is between these two graphs. We'll start with f of x equals x squared. We have done this graph several times. I'm just going to plot the points quickly and sketch in the parabola that we know we get. All right, so now let's take a look at g of x. And here we haven't graphed this one before, so I'm actually going to plot these points. I'm going to start with -2, 6, because -3, 11 has a y value that's a little big. So -2, 6 is right here. -1, 3 is right here. 0, 2 is on the y-axis. And then we've got 1, 3, and we've got 2, 6. If we do want to plot 3, 11, we do have to go up quite a bit because that's kind of outside the realm of what we have here. The same with -3, 11. And if we connect these into a nice parabola, because it's still a quadratic function, so we know it's still going to be a parabola. Oof, that's not the prettiest parabola. It should be a little bit smoother down there, but it is what it is. What's the relationship between these two graphs? What has happened to the original graph to turn it into the new one? And we can see here that each of these individual points is exactly 2 units above where the original point was. If we look at 0, 0, it goes up to 0, 2. If we look at 1, 1, it goes up to 1, 3. If you look at 2, 4, it goes up to 2, 6. So what has happened here is we have a vertical shift up 2 units. This is what happens when we add 2 to the function that we started with. What do you think would happen if we added 3? Well, all of these g values would be one more, it would go up one higher, and the function values give us the y value, so we'd be moving up even more. So by adding a constant to a function, we end up shifting the graph upward. Let's actually write this out as a rule. Suppose c is greater than 0. To graph y equals f of x plus c, shift the graph of y equals f of x upward c units, which is exactly what we did here. We shifted up 2 units. To graph y equals f of x minus c, shift the graph downward c units. Let's do another example, and let's use this instead of making another table of values. Now I want to sketch the graph of h of x equals x squared minus 2. What does this rule say about how we should graph this? Well, here it's y equals our original function minus 2, so that means we need to shift the graph downward by 2 units. So for every point on the original graph, we need to shift it down 2 units. So the point 0, 0 gets shifted down 2 units. The point 1, 1 gets shifted down 2 units. The point 2, 4 gets shifted down 2 units. The point 3, 9 gets shifted down 2 units. And we do the same on the left-hand side. All of the points that we plotted end up getting shifted downward by 2 units. And then when we connect the dots, we end up with a graph that looks something like this. In the future, if you need to sketch the graph of a function that is just a function we've done before, but plus or minus some constant, you can take the graph that you already have and shift it upward or downward by whatever that constant is. These are called vertical translations because they're shifting vertically. They're shifting up and down. So vertical translations. In the next videos, we're going to look at horizontal translations and also reflections.